Hi guys, welcome to Science in 5. In this video we're looking at the Theorem of Pythagoras, part 2. It's all about the application. The first thing we're going to look at is how to prove if a triangle is right-angled. In the previous video we said any right-angled triangle will have the square of the longest side equal to the sum of the square of the one perpendicular side plus the square of the other perpendicular side. And we said whenever you're applying the theorem of Pythagoras, make sure you identify those sides. We've got triangle A with sides 18,33 centimeters, 12,4 centimeters, and 13,5 centimeters. To prove if this triangle is indeed right-angled, we're going to have to apply the theorem of Pythagoras. The longest side in this triangle is the 18,33. So the 18,33 squared must be equal to 12,4 squared and 13,5 squared. Adding this to the calculator, we end up with 335,98 is equal to 336,01. But if we round off to one decimal place, the left-hand side and the right-hand side become 336. Triangle A is a right-angled triangle. What of triangle B? Well, the longest side is 60. Let's apply the theorem of Pythagoras. We're discovering that the left-hand side is not equal to the right-hand side. This triangle is not right-angled. Okay, let's move on. We can also use the theorem of Pythagoras to calculate distances on the Cartesian plane. How does this work? In the diagram below, O is the origin, A is the point 85. Calculate the distance OA correct to one decimal place. So there's the point A. First thing we just need to highlight is that movement along the x-axis and the y-axis, these movements are perpendicular to each other. If you move along the x and then you move along the y, you have turned through an angle of 90 degrees. This information becomes useful because now we can make a right-angled triangle. OA becomes the hypotenuse of that right-angled triangle. And we can easily apply the theorem of Pythagoras by saying OA squared is equal to one of the perpendicular sides squared plus the other side squared. The one perpendicular side is 8, the other perpendicular side is 5. So OA squared is equal to 89. Take the square root of both sides. OA is equal to 9,4 units. This idea of using the Pythagoras theorem on the Cartesian plane gives birth to this idea of the distance formula. The distance formula is a manipulation of the theorem of Pythagoras. It is more of an extension of that idea. But at this point in time, we'll not talk about the distance formula. We're going to stick to the idea of the theorem of Pythagoras and use the theorem of Pythagoras. The distance formula will be talked about later on when we do a lot of analytical geometry on the Cartesian plane. So that is how the distance formula is obtained. We've just spoken about x2 minus x1. This will be the x movement, the y movement, which is perpendicular. As a result, the d is the hypotenuse of those two movements. Got it? Okay. Let's see if you can apply these two ideas to this following problem. 3 points P, Q, and R have the following coordinates. P is -7, 3. Q is 5, -1. And R is 2, -10. Determine the following length PQ, QR, PR. Is triangle PQR right angled? Support your answer with a calculation. At this stage, pause the video. Practice this question. Practice makes perfect. Repetition results in mastery of skills. If you have skills in maths, your maths journey becomes more pleasurable and easier. Okay, let's have a look at how you could have done this problem. Given those 3 coordinates, the first thing maybe to do in this scenario is to make a sketch. Not a very convincing sketch, I must say. That's better, somewhat. The point P is at -7 and 3. So if I imagine that there is -7 and 3 is somewhere there, this is where my point P is. This sketch is not accurate. It's a sketch just trying to give me an idea of what I'm looking at. Q is the point 5, -1, 5 on the X, somewhere there, -1 on the Y, where these two meet. That's where the point Q is. And R is the point 2 and -10. So I go back there. I assume that's where 2 is. And that's where -10 is. That's the point R. To be able to calculate the distances now, I'm going to join these points with a line. So there's one distance. There's the other distance. So PQ, I can see PQ, I can see QR, and I can see PR. So using the idea of the Pythagoras theorem, I need 2 perpendicular sides. So I'm going to move along the X, then I move along the Y. From P to Q, if I move horizontally, I am moving from -7 all the way to 5. So from -7 to 0, that's 7 units. Then from 0 to 5, that's 5 units. It gives me a total of, that's 12 units. Then from 3, I'm moving all the way to -1. That's 4 units. For me to calculate the distance QR, I also need the vertical movement and the horizontal movement from Q to R. Q is at -1, and then R is at 10 in terms of the Y value, so the difference there is 9. Then the X movement is the 2 minus 5, gives me the 3. There should be a right angle there, there's a right angle there. Then PR, I'll do the same. There's a vertical movement, then there's a horizontal movement. So PR is the hypotenuse that I'm interested in. The X movement is from 2 to -7. That's a total of 9 units. So this is 9. The vertical movement is from 3 to -10. Gives you 13 units. Okay. Now we can use the theorem of Pythagoras to work out, for example, PQ. So PQ squared is going to be equal to 12 squared plus 4 squared. And therefore PQ must be the square root of 12 squared plus 4 squared. What is 12 squared plus 4 squared? Is 160. So it's the root of 160. I'll leave it as root 160, okay, just to avoid working with a lot of decimals. So PQ is root 160. QR, this is QR. I can work out QR using the same idea, is 9 squared plus 3 squared. So QR is the square root of 9 squared plus 3 squared. It's the root of 90. Then PR squared should be 13 squared plus 9 squared. Therefore PR is the root of 13 squared plus 9 squared. What is 13 squared and 9 squared? It's the root of 250. So, is this triangle a right angled triangle? Well, which is the longest side? It looks like PR is the longest side. It's root 250. And these two sides are the smaller sides. So if this is a right angled triangle, then the longest side squared should be equal to the one side squared plus the other side squared. So let's check that out. Okay, so we are checking if the root of 250 squared is equal to root of 90 squared plus root of 160 squared. Squaring both sides, you get 250 equals 90 plus 160. There we can see that 250 is equal to 90 plus 160. Both sides are equal to 250. So therefore triangle PQR is actually right angled. So there you go, guys. That's how you can apply the theorem of Pythagoras to prove if a triangle is right angled, and use the theorem of Pythagoras to measure distances on the Cartesian plane. Thanks for watching. Keep practicing maths. See you next time.